Okay, so welcome to this video on second order differential equations. I want to go through as quickly as I can the framework for solutions, so hopefully you've seen this before and there'll be links popping up for videos I've done going into the details if you haven't seen it before. But first of all, there's two types we need to solve. The one takes this form, and there are other forms of second order differential equations, but these are the forms you have to solve. So either you get this is equal to 0, okay, and what we do here is we write what we call an auxiliary equation. So we write m squared plus am plus b equals 0. We solve for m. There's three cases, okay, so there's case 1, and that's 2 real roots. Case 2, 1 repeated real root, and no prizes for guessing case 3. That is no real roots. And all these lead directly to a general solution. Okay, so immediately by establishing which case it is and finding those roots, if there are them, well, in all the cases you have to find the roots, that will lead us directly to a general solution. You can look those up. Okay, the next case, which is very similar, is the same on the left hand side. Plus by, but it's equal to some function of x, okay? Now, what we do is, we essentially split this into two parts. So, we solve this section equal to 0 first, okay? And to do that, we revert back to this, and that gives us what we call a complementary function, okay? So that's the complementary function, and then we just find an integral and a function that when substituted into here solves this equation, and we call that a particular integral, okay? And this particular integral is essentially just a guess, but we obviously check that it works and find that the constants that allow it to work. We can make an educated guess based on what this function f of x is, and there's tables and the like, so that you know what to guess or what type of functions to try and guess at particular times. And yeah, the complementary function plus the particular integral gives us our general solution for this form of equation. Why is this? Well, the complementary function, when plugged into this differential equation, is 0. So we've got something here that when it goes into here is equal to f of x. This is equal to 0, so those two things together give us a general solution that's still equal to f of x, okay? And obviously this complementary function, when I say equal to 0, it's a non-zero function, but when you take its second derivative, add a times its first derivative, and add b times the function itself, you get 0, okay? That's it for a run through. I've got lots of videos on the particular details of this, so I'll leave them, like I say, all linked. So if you need help with case 1, 2 or 3, you can get that. If you need help with what to pick as your trial functions, I've got videos on that and such. So thank you for watching this video, and I hope to see you in the next one.